Today's lab is going to focus on using technology to perform both chi-squared tests we learned about in class, as well as an analysis of variance. To begin, let's start with the chi-squared test for independence. You'll recall that this is useful when you have two categorical variables and you'd like to see if there's any dependent relationship between them. So we have before us the students 15 data set that we've used in previous videos. And today we'll start off by looking to see if there's a relationship between primary major and whether or not a student is international. Now, the chi-squared test in Minitab can be run under the Stat menu. If you scroll down to Tables, you'll see there is a cross-tabulation and chi-squared option. That's the one you want to choose, not this chi-squared test for association. So when you enter this, usually there'll be blanks. Of course, I've run this before, so you can see things popping up in my fields. But enter primary major into the first row field, and then international into the columns field. And then down here, you can choose to display the values, the observed values, either as counts, row percents, column percents, or total percents, kind of like in Excel's pivot tables. And then you can also choose to have it display various chi-squared statistics, like, for example, to do the actual chi-squared test, give you a p-value and whatnot, to give you the expected cell counts, the contributions to chi-squared, etc. Right. So when we run this, notice we get an output which consists of, for every single cell in our table, we have the observed count. For example, there's 59 students who are not international in business. We have an expected count, and then we also have the chi-squared contribution for that particular cell. At the bottom, we have a chi-squared test statistic, degrees of freedom. Right. And notice that in this case, it failed to provide us with a p-value because it has all these warning messages. 3 cells with expected cell counts less than 5. And that's because when you run a chi-squared test, really using the chi-squared distribution assumes some sort of larger sample size. And the rule of thumb they often use in software is that any cells which have expected counts of less than 5 are considered too small. So looking back at our table, we can see that one of the issues here is humanities, and another is the social science group, right, where we have very few in this category. So this will often happen when you're working with your final data. So I wanted to show you some tricks to how to get rid of these values. The thing you should do in Minitab is create a subsetted worksheet, and this can be done under the data menu, the first option there. So when you subset a worksheet, you can either specify the rows to include or to exclude. We'll specify which rows to exclude, and then rows that match a condition. So under condition here, it's already entered in my Minitab here, but if not, you just click on the variable name. Let me show you so you can see the whole process. Right. And then type equals, and then the value which we'd like to exclude. In this case, let's exclude the humanity majors. All right. So when I do that, I get a new subset worksheet pop up. Right. And this new subsetted worksheet is similar, except it has all humanities majors removed. So now if I go back to Stat, Tables, chi-squared, cross-tabulation, and chi-squared, I can rerun my test. And notice it does still tell me that it notes that one cell has an expected cell count of less than 1 because there still is this social science cell. But at least now it sort of considers this good enough to run the test, and it outputs a p-value of practically 0, which means there's pretty significant evidence of a relationship between major and whether or not a student is international. And if you look at the actual chi-squared contributions, you can see there's a particularly large one for international business majors because there's a lot more international business majors than we would expect in our data, right? And so that is what's kind of contributing most greatly to this chi-squared test. Now, to run a chi-squared goodness of fit test, which you'll recall is useful when you have a single categorical variable and would like to test it against some hypothesized distribution, you can also go to the Stat Tables menu, and you'll see there's a chi-squared goodness of fit test option. So for this one, you can have some different options here for what to do. What we're going to do is put categorical data because we actually have rows of categorical data in our data set, not the actual table of counts that we're working from. And so what we'll do, let's test the hypothesis that majors are evenly distributed throughout the class, right? Which would mean that 1/4 of all students were business, 1/4 ECS, 1/4 natural science, and 1/4 social science. So we'll test these against equal proportions, and we'll click OK here. And notice that we get a couple graphs out here, which are bar graphs of the the number and the counts of observed majors in each group, right? We also get a comparison of the expected and the observed counts, and we can see that business is much more than what we expect under the equal model, and engineering and computer science is actually much less, as is social science. And if we look at the actual output here, we get our observed counts, our test proportions, our expected, our chi-squared, and then our p-value at the end, which in this case tells us, of course, that there's no way that this is equally distributed in the class, right? Business majors are way too dominant. Right? The final type of test you'll need to do in this lab is an analysis of variance, which you'll recall is useful when you have a numeric response and you want to compare its average across different groups. So to illustrate this with the example we did in class where we compared risk scores between the different major groups, to do an ANOVA in Minitab, you simply click on the Stat menu, go to ANOVA one way, and for most situations that we'll be dealing with, we'll use this response data in one column. This is what you use as long as you have one column, which is the numeric variable, which records the responses, and then a separate column, which actually gives the groups. There are certain situations where you might get data in a different format, but that's sort of the standard form we've been working with in this class. So if you have your data in that form, then we enter our numeric response in this column and our factor, primary major, in this column. And notice that actually you can have it automatically generate box plot, which is a useful kind of graphical display of the results. And then when we click OK, we get this box plot. And we can see that of all these groups, social science majors had the highest mean risk score, while natural science had the smallest. Right? The interval plot, what that does is it shows us the means for each group, the sample means, along with 95% confidence intervals for those. And the social science one is much wider than business, for example, because the sample size is much smaller here. And then finally, in the very back, we can see here a whole bunch of items were output by this test. The very first one, which is the important one for our purposes of hypothesis testing, is this ANOVA table, similar to the one we looked at in class. It has your sum of squareds for the treatment and for the error. It has the adjusted, the mean squared errors, which is the sum of squares divided by degrees of freedom. And then it has the p-value, the ratio of the mean squared treatment to mean squared error. And finally, the p-value, or the right tail area under the F-curve. So in this case, with the small p-value, we can see that we can reject the null and conclude that the different majors do have significantly different average risk scores. And you'll notice if you scroll further down that it gives you some useful summary information here. It gives you a breakdown of the counts, the sample means, the standard deviations for each of the different majors, as well as 95% confidence intervals for the means of each major, and these can be useful in your analysis as well.